All right. So yesterday you guys were taught about integrals very, very abstractly. Just to make sure you understand that integral is just finding area underneath the curve. That's how you can think about it. And if we have enough time, we can talk about what that actually means. Like, why would someone think to do that? What could it represent? Okay. So for today, we're going to talk about finding upper and lower sums for a region. So if you remember back to the last video, I was talking about how you have like overestimates or underestimates. So that's kind of the same idea for the upper and lower sums. Like what's the lowest amount we could possibly kind of estimate it to? What's the highest amount we could anticipate it to? So like between what two numbers should our answer be? So to help us with that, we're going to find the upper and lower sums of the region bounded by the graph of f of x is equal to x squared and the x-axis between x is equal to 0 and x is equal to 2. So what I want you to do is be familiar with how to take this sentence and, this part right here, you're trying to figure out the region bounded by the graph between the x-axis and x equals 0 and x equal 2. That underlying part is kind of asking you from the x is equal to 0 to x is equal to 2, x is equal to 2 of the curve bounded by the x-axis. That's what they're kind of asking to do. But the issue is that this part right here is we're trying to estimate it. Right? So that's what we're really trying to do. So the best way we can do this is to kind of draw ourselves a little bit of a picture. So if I consider what the graph would look like, right? So I know that x squared is a parabola. So it should look something like that if I had better motor skills. But I don't, so I'm just going to kind of compensate. There we go. Cool. So that's what I have. So specifically, I'm trying to find it between x is equal to 0. And let's say this is x is equal to 2. That actually looks like a 1. All right. 2. All right. So in this instance, I can think about the lower and upper estimate. So I don't have a lot of information to go with. If I was given the number of triangles, or I'm sorry, rectangles, sub-intervals that I should have, then I can easily do that. But since I don't, I'm going to go ahead and give you more information so we can actually solve this problem out. I want to divide this into 5 equally spaced intervals. All right. So I need to take that part of the graph and break it up into 5 spaces. So I'm going to go ahead and zoom in so we can do a better job. Okay. So if I'm breaking this up into 5 spaces, I'm going from 0 to 2. So from 0 to 2, that's 2 divided into 5 equally spaced intervals means that I should break it up into intervals of 2/5. So starting there, 1, 2, 3, 1, 2, 3, 4, 5. Like, you guys get the picture I'm trying to go for. I didn't do a great job, but I tried. Okay? So, if I'm doing the lower estimate, I have a choice. So, right here, all the lines I drew intersect with the curve. I could draw from that intersection point of the pink lines to the purple lines, or magenta lines to the purple lines, or curve. I could draw it going left or going right. One of those will represent and the upper estimate. One of them will represent the lower estimate. So technically, if I do the lower estimate, it goes from here to there, here to there, here to there, here to there, here to there. Right? So it would be the area of these rectangles here. Because if you notice, it should produce an underestimate, a lower estimate, because there are some white spaces in there that are not going to get counted. And that's fine. So I know each of the rectangles, right, will be base times height. And the base is 2/5 because each of the triangles are 2/5, like that's their base length. That's how I split it up. But the height changes. The height depends on where it would be, like on the curve here, right? So here's what I have. I have the curve I was told was x squared. And I know this is 2/5, 4/5, 6/5, and 8/5. And 0, of course. All right. So if I think about where I drew the rectangles for the first one, it was starting at 0 and it went all the way across. So it would be 2/5 times 0 plus, well, this one went up, then it went over. So starting at the 2/5, that's the base, times the height would be whatever I get from 2/5 squared. Because that should tell me that part of the graph, because it should be when x is equal to 2/5, how far off the ground it should be. Plus, and again, the base is 2/5, but now if I do the next one, it goes up to here and it goes over, and that's starting at 4/5 would be 4/5 squared. Plus, and hopefully you guys are getting the rhythm for how this is going, 6/5 squared plus, because again, right here at 6/5, I go straight up, then I go over to draw my rectangle. So that's how I get my height. The base is still always 2/5. 2/5 times 8/5 squared. So this last one going all the way up and then going over, right? That'll be where my area is located in these purple boxes here. That's what these numbers I'm going to get will represent. I'm hoping my touchscreen doesn't break or stop working. So if this is what I have, this is kind of a lot to do. So if I have a calculator, I would just plug this in. But right now I don't have a calculator. So I'm going to factor out the 2/5, aka the base length that they all have in common. And it should be 2/5 times 0 plus 4/25 plus 16/25 plus 36/25 plus 64/25. Okay? So all these just represent the actual heights that I was given. And if I do so, get my face out of the way, I should get 2/5 times, let's see, 0 plus 4 plus 16 is 20, 36 plus 64 is 100. So it'd be 120 over 25. which should be 240 over 125, which all those numbers are divisible by 5. And that should be 48 over 25. That would be the lower sum. So I know that the integral that I'm looking for has to be at least 48 over 25 units. Okay? And hopefully you understand why it's lower. So now I'm going to pause, and then I'm going to clean this up, and we'll get started with the upper limit. The upper sum. All right. So cleaned it up. Now we're back to the graph, which is still the x squared. Make a little note of that. And I still have the 5 subintervals, so now I'm going to draw them out. 1, 2, 3, 4. So 1, 2, 3, 4, 5. All right. So now I'm going to go with the upper sum. So now I'm going to draw the rectangles going out. So depending on what kind of function you have determines on if the drawing left or right would be a upper or lower sum. Right now, just by drawing this, I can tell this will be an upper sum because the rectangles have these parts that are outside the line. Right? So this is still the 2/5, the 4/5, the 6/5, 8/5, and 2. So now I'm going to find the area of these rectangles here. Right? So since there were 5, I'm using the 2/5. I'm just going to set up my structure. Right, there's going to be 5 of these. All right. So if I think about this first rectangle that I have, it goes up and it goes over, and the height of that would actually be from the 2/5 squares. So now I'm going from the ending point there, right? The other one would be from the 4/5 going over and then back down to draw it out. And the next one would be that 6/5 going up, then over and completing that rectangle there. Then the 8/5 goes straight up, goes straight over, then comes down to build that rectangle. And the last one goes from here all the way up to this endpoint, goes all the way over, and then comes all the way down. So that'd be 2 squared. And again, since I'm trying to add these up and I don't have a calculator, I'm going to go ahead and do a little bit of light factoring. Factor out the common base of 2/5, and I'm going to have to end up adding 4/25 plus 16/25 plus 36/25 plus 64/25 plus 4. All right. So I end up with 2/5 times, let's see. So I'm going to write the 4 over as 100 over 25, so I have a common denominator. So 100, 200, 220. So 220 25ths. Wow, that can't be right. I must have added wrong the previous problem. Oh well, we'll double check. So doing this gets me 440 over 125. These are all divisible by 5. So I got 25 over, let's see, 88. All right. Hopefully someone is double checking my work because I don't have a lot of faith in myself right now. Yeah, no, it's 88. All right. So then, my lower sum was 48. My upper sum is 88 out of 25. So somewhere in between those two, if I did more and more intervals, right? So I only work with 5 intervals, but if I had done 10, I would have gotten a smaller range between the a smaller difference between the lower and upper sum. If I'd done 100, even smaller range, they'd be closer and closer together. They wouldn't be exact, but they'd be a lot closer. So hopefully this helped to show you how to find the upper and lower sums when they ask you to use the intervals. Yeah.